Here's a doozy. We have to figure out the rate law for this reaction. Well, I'm not showing the reaction here, but the reactants are ClO2 and hydroxide. To figure out the rate law, all we really need to know is, how much does the rate change when we change the concentration of one of these by a certain amount. Here's what I mean. So the first two experiments, this is 3 different experimental trials where the initial rate was determined. And these first 2 experiments, the one thing that was changed was the concentration of ClO2. So it's important to note it's actually 3 times greater in experiment 1. 0.06 compared to 0.02. So if ClO2 were a first order reactant, we would expect that the rate would be 3 times bigger in rate 1, just like the concentration was 3 times bigger for experiment 1. What do we actually see in terms of rate difference? We see this ratio that's, it looks like 10 to 1, but not quite. It's pretty darn close to a 9 to 1 ratio. So just to recap, we saw a 3-fold change in the concentration of ClO2, but a 9-fold change in rate. And what we're trying to find is the order of ClO2. So what we would have to do is to square that concentration to get our 9. So to try to explain that a little more clearly, we find the factor by which we change our concentration, which is 3 times, and ask ourselves to what power do we need to take that to get the difference in rate. So 3, we need to square it to get 9. So that's a power of 2. Therefore, in our rate law, we square the concentration of ClO2. If you can see what I'm saying with this, you're golden, you're good to go. But here is a mathematical trick to figure out the order, that power that we have to take the reactant to. So part 1 of the trick, write out the rate law with these unknowns for your orders. M and N are usually used. Step 2, write out the rate law for the same rate law basically, but for the second experiment. So same thing, only whatever concentration we used in the second experiment goes here for ClO2. And then just divide one equation by the other. And that allows us to cancel out anything that didn't change. So K is a constant, that goes bye-bye. We didn't change the concentration of hydroxide, so it cancels out. And on the right side, we're left with this. And the left side, we have rate 1 over rate 2. We found that ratio to be 9. And now I'm just going to rewrite the right side of the equation so that we can just stick in here the ratio of concentration in the first reaction over the second reaction. Remember, the concentration was 3 times greater in the first experiment. So I'm going to put in 3 there for this ratio, and our equation becomes this. And maybe we can look at this and see that 3 must be raised to the second power in order to get 9. Alright, so that gave us our order of the ClO2 reactant. Now let's figure out hydroxide. So to figure out hydroxide, we have to look at the difference between experiments 2 and 3, because that's the one where we change hydroxide concentration but nothing else. And what we did was we tripled the concentration. So let's think about it this way. If hydroxide is a first order reactant and we triple its concentration, we would expect the rate to also triple. Is that what we see? Well, let's look at the ratio of rates here. Rate 3 over rate 2 is 0.008 over 0.0027. Yeah, that's about 3. So yes, hydroxide is a first order reactant. So its exponent in our rate law would be 1. So here's what we knew going in. The point of this problem was to find M and N, so I'm going to go ahead and put in the numbers that we found. And that would be your rate law equation for this reaction. Part B is to solve the rate constant K. So I've taken our equation and rearranged it to solve for K. We isolated K. But here's the trick. Here's something to point out here. The numbers that we put in are going to be the numbers from one individual experiment. So we can't mix and match numbers from experiment 1 and 2. That wouldn't make sense. Let's just pick experiment 1. So I'm going to put little 1 here to say we're going to take the rate from experiment 1, the ClO2 concentration from experiment 1, and the hydroxide concentration. So those should be all our values from experiment 1. And again, the units is a tricky one. Let's do some unit math. So the rate is molarity per second, and then we got a molarity squared on the bottom. That's it. And then another molarity. So, oh boy, we cancel molarities and end up with 2 on the bottom and 1 seconds on the bottom.